This is one of the most exciting parts of Effectopedia, at least for me, where we can run interactive executable models written in different programming languages, R or Matlab, for example. And hopefully this module and this part of Effectopedia will facilitate the communication between risk assessor communities and modeling community, and also involve the experimental designers and make the whole collaborative effort much more efficient and produce much better results at the end. So if we go to Effectopedia, your Effectopedia test database contain one example model. So if I go and look for all the available AUPs, the last in-silico model tester pathway fragment includes several quantitative models. Those models are all embedded, in this case, in the prediction between predicting MIE1, but in-silico models could be embedded into other links as well. For example, the link between the two key events or two chemicals when we have to add toxicokinetic information. So those models, as you can see, are written in different languages. The first one is written in Matlab, this one is R, and this one is Java. And if I double click on any of those models, the model description is loaded. It starts with a link to the associated global model, and the global model is the part where authors are actually required to describe their model. This first model is very simple linear MATLAB model, so there is an abstract of just one sentence which describes that this is linear model. It has two parameters, interception and slope. For each parameter we have the default value of the parameter, the normal range, and if we have more descriptors or references we can supply them here. Further down, the model consists of also some resources. So we have initialization code, which is generated by Effectopedia, and the model itself is described as this simple MATLAB function, which uses the input of the model to calculate the output of the model, and the output is calculated by simply multiplying the model slope by the input value and then adding the intercept. As you can imagine, though, this model is very simple, and other models might require calling additional source code, so you can add this as additional MATLAB source code, or you can also need to provide some curve fitting data, and you can add those as resource as well. However, this level of detail might not be so interesting for everyone, so Effectpedia provides slightly more user-friendly and easy to access interface for the model, and I just clicked on the another model supporting the same MIE, which is R model, and it is creating a dose response curve based on this simple Hill type equation. And we can have more elaborate description here using MathML, so you can see the formulas in more readable format, but this has not been done in the example itself. What is important is where we can actually run the model with specific settings. So here we have added one chemical structure, and the model takes as input, in this case, concentration of the chemical and also the model parameters. And here for the concentration we have a nominal concentration and measured concentration. And for model parameters we have the 5 parameters that were listed in the Hill type equation. So if I choose to run the model, I can select the auto execute option and then click on execute, and this will show me what the model output looks like for those specific values of the parameters. But what becomes more interesting is when I actually drag the parameter, I change the value of the parameter. Effectopedia creates this initialization file again, sends it to R. R makes the calculation and returns in real time the output of the model so I can see the result. So what you see as the shaded curves are the previous values of this parameter, and the more brighter and prominent curve is the current value of the parameter. As you can imagine, this is really more helpful when you don't understand how the model behaves to query and interact with the parameters. We also have those descriptions here provided by the authors, which really help us to interpret the parameters. But all of those features actually require for R to be installed on your local machine. And while we think to provide simple scripts to install R for the future releases of Effectopedia, and also for all the other languages that we might support, like Python, Octave. But in case you don't want to actually work with those dedicated special tools, you can do something else. So Effectopedia provides this preset interface. Here we have a number of presets, and those are executions of the model with specific parameters. So in this case, only the parameter that has been changed from the default values is listed in the title of the preset, and you can just page through different presets and see their output here. So if we want to actually create a new execution request, so we are interested, for example, of what will happen if we change the parameters of the model to those values, minus 55 for kill slope. We can increase a little bit the max response and increase also the minimum response. So once we are ready with the parameters as we are thinking they should look like, we can actually add additional execution requests, and this is what it looks like. And we can also provide a question to the authors. This set is interesting because, and provide some justification why you think this is really interesting to calculate. Then you can publish this execution request into the test database. And once the author on the other end sees the published execution request, because they have R installed on their machine, they can click the calculate button, and this initial execution request is now converted to preset. So once they publish this new preset, you will be able to see it, and also maybe some additional comments from the author why the model behaves in this way. Hopefully this feature will be used for communication between, let's say, risk assessors who understand the biology and know how this chemical, for example, need to cause the MIE, but they don't understand the model itself, so they actually can query the model with those sliders and see if it behaves like they expect. We also expect this to be useful when model developers need to communicate with the experimental designers what type of parameters they need in order to calculate the output, and if those parameters are something that could be measured in experimental design and provide some initial values and normal ranges, that will be something also very valuable. So hopefully all of these interaction mechanisms will facilitate the development of quantitative models. We have a question, does Effectopedia support assessment of other stressors than chemicals, for example, UV radiation, temperature, etc.? Effectopedia internally implements Initiator, a class to be what triggers the AUP. And this Initiator class has currently interfaces for new chemicals, structural alerts, or biological perturbations. And the reason we have separate interfaces for those is that we can provide more structural information for each individual initiator. So if we were to add additional box here for initiators that are very general, we might need to add something like a physical environment, and there we can describe the temperature and radiation and so forth. But that's easily done, so we just need to figure out what is the really good structured way to capture this information. Another place where such factors as temperature might be useful is when defining the modifying factors of the links between the key events. The next release of Effectopedia will already have a list of modifying factors. This list in the current release that is upcoming is only covering key events and chemicals as possible modifying factors. But in future releases, we can also include those type of modifying factors as the initiators. We can also imagine that some more sophisticated in-silico models can include temperature as a modifying factor of the um, model relationship. So if, for example, we give temperature as one of the input parameters of this in-silico model, it can change the magnitude of the relationship between the MIE1 and key event 1. And we can also imagine situations where temperature is really important factor. Let's say in hatching egg, some vertebrates, the sex depends on the temperature, so this will be even more important factor there. With this, we hope to be able to capture much broader ways of disturbing the normal biology and include them as part of the normal AUP description.